data scientists? Are you developers? Just so I know who I'm talking to.
I have a CISSP. We adopted 2 kids from foster care, so this is very interesting to us
Okay.
because I'm familiar with CBC.
Okay.
And obviously, I played with data science in my job in the IT stuff.
Okay.
And data scientists at companies like Netflix, director of SaaS software, and
Okay.
startup here that's in the data analysis space.
Okay. And you?
Computational social science PhD. I build models of complex social systems, and I'm very interested in this. I'm curious.
Okay. Okay. So to introduce myself, my name is Kevin Cobb. I did both my bachelor's and master's in civil engineering in Urbana-Champaign. And then after my master's, I did 1 year with the U.S. Geological Survey doing rainfall research. And then I've currently been a data scientist with Itron for 2 years now. They make the electric meter that you can find in your house that measures your consumption. So we work on applications like outage detection, load balancing, theft detection. So like on the infrastructure level. And then I've also been teaching data science with Thinkful for a year. And throughout my college, I was always involved with Engineers Without Borders. So I even traveled to Cameroon for a bridge project. And when I became a data scientist, I just looked for the equivalent organization, and I found that to be DataKind, and that's how I ended up volunteering. So I signed up for their mailing list, and even the first time I applied, I got rejected. It just matters like when they have a project that fits your skill set or your experience. And last year in October, they sent out a newsletter, and they said they were opening a project here in Orlando, and I've been in Orlando for a year and 2 months, so I was like here for 2 months already, and I decided I wanted to get involved in a local project. So I applied, and that's how I ended up on this project. So before I could go through the presentation, I want to just give credit to the rest of the team and the rest of the people involved because most of the slides that are in this slide deck were ripped from our presentations that we gave to the project partner and to DataKind. So for those who don't know what the CBCCF is, so Community-Based Care Central Florida, so they're a nonprofit organization, and they deal with like troubled youth, kids in unstable situations. So they deal with foster care, adoption, and diversion. Diversion meaning like if the household is unstable, they work with them to so that they don't have to take the kid out. They try to make the environment more comfortable for the kid. So they also have other programs as we learned. So they have, let's say you're a minor, you're 16 years old, and once you hit 18, you graduate out of the CBCCF system, and they don't take care of those young adults anymore. So they prepare, it's like you're older, like 16, 17, and you don't have, you're not being adopted yet, then they start to train you they start to give you livelihood training so that you're prepared when you get out of the system. So I invited the we did this project with the CBCCF, and one of their IT people helped us in the project. I invited him today, but he couldn't make it. So yeah, I hope I'm doing a good job in explaining what the CBCCF does. So the problem with this is a graphic taken from Ohio's equivalent of the CBCCF. So in 2016, 1 out of 7 caseworkers left their job, and this is because of too much work and emotional toil of the job. And the, this is the important figure. It costs $54,000 to replace a single worker, and this is because um, in in order for new employees to be able to handle cases, they need to go through at least like 120 hours of training. something like that. So what happens is that it's also very damaging for the kids when they have to change caseworkers assigned to them. And basically, this was the main problem that CBCCF had, and they wanted to find a way to kind of at least help reduce the amount of workers leaving every year. And this is why it's such a big problem. So in the equivalent in Milwaukee, what they saw was that kids with one caseworker throughout their case duration have permanency, so they achieve they're able to find a stable household to join or get adopted, and they achieve permanency 75% of the time. Whereas if there's two caseworkers or more, or two caseworkers, it drops to 17.5%. Yeah.
Was that maybe because very difficult children might get escalated to somebody who's more experienced, maybe with that kind of problem, and trying to? Does that make sense?
So based on our interaction with the CBCCF, it seems like special cases from the get-go get handled by special caseworkers, but then in general they don't do escalate. They don't have escalation. So your escalation can be like on the program level, like they decide you need to attend this therapy, but it's still the same caseworker.
They usually go to the supervisor to say, hey, what do I do? But that caseworker will be assigned to that kid unless they quit.
So it's still the same caseworker managing that case. Although they're interacting with other programs, it's still the same caseworker. Okay. So CBCCF was the one that initiated contact with DataKind, and they came with a very broad problem. How do we lessen the amount of caseworkers leaving? And based on the data they had, DataKind scopes out projects before they're assigned to volunteers, and there were two projects that came out of this. So the first one was a scheduling optimization tool. So this would allow caseworkers to efficiently do their tasks. So if, for example, they had the case visit in location A, and they had the case visit scheduled the next week in nearby location A, then we could juggle those around so that they could just maybe hit those two in one stop. And the second one, which is the main talk today, will be measuring case complexity.
Can I add one thing to his
Yes.
question? Because we went through the adoption process, I can talk about the outside in. As a parent, one of the challenges was we're used to working with one person to learn about kids that are assigned to that person. You're emotionally invested. You're 3 months in, you're 6 months in. You've been chosen to meet the kid, and the caseworker's not. You have to start it all over again. Well, it's like losing a child, and you're ready to give up. Also, you don't have a person who's following the kid through and can advocate for it. So there's all kinds of broken issues on both sides. The kid has trouble trusting because they've had a person in their life, but so much has been lost. But also the people who are interested in adopting the kid haven't pulled away. So it doesn't just affect the kid, it affects people who would otherwise adopt the kid because they've lost their point of contact.
I wasn't aware of that. We never discussed the families when we go through the data and stuff. So the expected timeline for this project. So this started October last year, and by early December last year we formed a team, and the target was that by June 2018 we're able to hand off. This is what actually happened, and we're still in the handoff process, although it's going. And a lot of this, I would say, by the end of it, we got delayed around 2.5 months. I'd say a lot of it was really just understanding the volume of the data, a lot of messy data, and a lot of, we were always learning something new about the data every step of the way, and I'll explain more about that. So the project structure, we were 12 people, 12 volunteers, and I myself was the project manager. And then we had the data ambassador who is responsible for communicating with the client, so in this case the CBCCF. And then we had 2 tech leads for each of those projects. And under those tech leads, we had 3 members each. In the very first month, one of the members left, and then later on, someone was kind of in and out. So what I did for this project was, as a project manager, I also eventually assumed the data ambassador role, and I also helped out in the complexity project in the data science. So these two projects were kind of related from the get-go, and they wanted to see if there was a way to integrate them. So they were thinking that, maybe if we can find out a caseworker's route and see where they're going at, geospatially, maybe when we assign new projects to them, or when we measure case complexity, maybe it's also a factor of how much they have to travel in order to deal with that case. So, for example, the best example of this is cases with siblings. So a lot of the times, kids with siblings, like, they have to visit their other siblings, and they may be spread out. So that becomes complicated for the caseworker. But if they're also in the same household, then the same caseworker could easily manage both of them.
Can I take a second?
Yeah.
The requirement is, correct me if I'm wrong, the caseworker visits each kid once a week to check on if they're healthy or not, right?
Oh,
Or
I
is
think
it every 2 weeks?
I think it's once a month.
Once a month, okay.
Yeah, once a month.
Once a month.
Yeah.
But if the sibling is supposed to visit the other sibling, then someone has to transport them. So in that visit, you could do the monthly check, but then think of all the different ways they're heading, UPS runs and all that, but your kids are everywhere, one for sick, what if they're not available? You've got to schedule with 2 different foster families. So the geospatial component of getting together and seeing them is huge, because you can't see them during school hours. So there's the burnout for the workers, because they're doing a lot of this in the evening. I just want you guys to understand why it's more complex than just delivering an Amazon package to a house.
Yeah. So also, like, if a caseworker already has cases around a certain area and a new case pops up there, the hope would be that that caseworker gets assigned that case, or at least that's factored in when they're deciding who will take that case. So I'll briefly go over what happened with the scheduling optimization tool, and then the rest of the talk will be about the case complexity. So for the scheduling optimization tool, the goal was to make something for caseworkers to use on a weekly basis. So their scheduled activities are already in a database, and that would come in. And once it's loaded in, we could optimize, move stuff around, and hopefully save them time when they do their tasks. And the main requirement was that they asked us that whatever tool we make has to be flexible, because they said a lot of times, a lot of emergencies happen, a lot of stuff pops up, and sometimes tasks have to be bumped. And they said we need that flexibility to re-optimize or rearrange as needed. So the end result of this was we made an Angular app for the caseworkers. One of the requirements that came up eventually was that it has to be Internet Explorer compatible. That was pretty damaging to us. It took a bunch of work getting that, but yeah, in the end, what we did was I'll just go ahead and show the UI. But on the back end, we use Python, MySQL, and we use a package called PyScheduler, and that had solvers for mixed integer programming. So we mainly use that to organize. So what we did was, when the activities came in on a weekly basis, we got the geospatial coordinates, clustered them, and then the ones close together we put in the same cluster, and the ones activities in the same cluster were scheduled to be on the same day.
Were you able to factor in travel time as well?
Yes, also.
Okay, perfect.
Yeah. So this is the UI that we gave them. So on the left is how you add an activity. On the right, activities could already be preloaded, and they can even add personal activities here. We just told them that there's a disclaimer here that says that other people in the organization can view your activities, so don't put anything too personal. But that was a feature they requested, so we gave that. And then you can mark completed activities. So if you click an activity, you could easily delete it or update it. And over there, there was activity that changed its status from completed from no TS. And then you could start you could set your start and end points. So some of these caseworkers, they go from their house, or they don't end, or they end at their house. So we give that flexibility. And then the optimizer. So once we got the locations, we made a distance matrix by querying Bing Maps. We use the Bing Maps API for this. And Bing Maps also has they have licenses for nonprofits. So this worked well also for a long-term solution because the CBCCF can apply for those. So once we make the distance matrix, each activity was manually labeled. So, for example, a monthly visit we estimated to be 60 to be 1 hour. So we use those set durations. So the CBCCF gave us a long list of activities, and we asked them to estimate a duration for each one. And then the travel there is calculated from the Bing Maps API. And then once it's optimized, you could rearrange the activities. So that's the reordering of the activities, clicking the arrows. And then one of the features they requested was that once there's an optimized schedule, they asked that there's some functionality where the manager could email that schedule to a caseworker. And then here, just setting the maximum allowable time for each day. That will be factored in the optimizer. And then if you need to do a certain task at a specific day, we also allow them to input those constraints. So, any questions on optimizing? Yeah.
Did you pilot that, or are they using it now?
That was piloted. Deployment, I think, already finished. And based on the initial estimates, what was published in the blog entry was that they save on the order of 30 miles a week.
I know that that's huge. It's
Yeah.
gotta be huge. It's gotta be.
Do you have a question?
It might be best to ask it again, but I found it curious at the very outset that problem space immediately went to time and space, distance, basically, and that it was driven entirely by caseworker burnout. I'm kind of curious why those were decided initially as the first problem and the first solution.
Yeah.
When there may have been an entire panoply of other problems that could have been equally well addressed, perhaps in less costly or more effective ways.
Yeah. I guess what you're saying is why did we assume that we need to help the caseworkers lighten their load, whereas maybe we could have looked at the data and we could have seen what are the factors that make people quit, right?
Yes.
That's
When we
not
study turnover in general,
right.
that's why I think it's fascinating that you say, make them be more efficient with their driving. So were they exempt from the wage and hour laws so that if they had 10 assignments and it took them 8 hours to do it, they had to do it each day and they only got paid 40-hour week? Because that makes a big difference. Then you're saving 30 miles is a big deal. If they're hourly and they just do what they get done and the amount that they're paid for, this is nice to save gas for the state.
Yeah.
So
Yeah.
where's the background?
So
Why is this? How is this helping the caseworkers?
I can't answer this specifically because what happens is DataKind is the one responsible for scoping the project before it's handed to the volunteers. But I will say though that looking at the data, their main the main amount of data is focused on the cases and the case notes, and I would say that on the caseworker side it's kind of lacking. Maybe in the future it could be done, but we already used kind of the main source of data, and we found that we could have used more certainly.
One of the things in my field customer said this is the problem, you guys were hired to fix it. Does that kind of boil it down?
Yeah. So DataKind is that.
That's fine.
Yeah, DataKind is that person, and then it got handed over to
It
the
also
office.
looks like a more tractable problem, because many of the issues that face caseworkers, I'm sure, in burnout caseworkers are social and psychological issues that are not nearly so easily addressed as violence.
And we have a lot of history and we know how to solve an optimization problem.
Let me address the word. Burnout versus leaving. A lot of those guys are first workers, and they go in and say, this wasn't for me, and it has nothing to do with the job. It has to do with.
I understand. I also have a degree in psychology, so I'm familiar with the notion of burnout, which is why I didn't become a psychiatrist. But this is what we call complex.
It's
Not
the
just
tail wagging
complicated.
the dog
Yeah.
by them leading in and saying, we think this is the problem, when it's really something else that can be fixed.
We have to watch and see if he's going to tell us if it's successful.
Yes. Yes.
Yes.
Was the decision to use Bing Maps API made before or after you were forced to use IE?
Before. I think with Bing Maps, Microsoft City sponsored this project, and they gave us virtual machines for it.
That makes a difference.
So that's probably related to it. But we were also exploring Google Maps. Yeah. No, we were not. Yeah, I don't know why.
That's all 99 quarterback. Just ignore that.
Okay, so on to case complexity. So the problem statement was that the current method they use for assignment leads to case imbalance. So what they did, or what they do now, is that they say, okay, caseworker A has 10 cases, and caseworker B has 9. So the next case that comes, they throw to the person with 9. So there's no insight into how heavy those cases are, and it's just on the sheer amount of cases. That's the only metric that they use. So the goal was to allow managers to kind of measure the actual workload that the caseworker had, and one of the requests, or one of the ideas CBCCF had also, was that if you're aware that a certain caseworker is really good at a certain type of case, like maybe they're good at runaway kids or something, then you would hopefully get those cases and pass that to the caseworker. And also, back to the siblings, if you know where the caseworker is already operating, the hope is that you can get them cases in similar locations. So, just the general timeline of how a case happens. So first, there's an allegation, and my understanding is somebody just calls and says, hey, I heard a kid crying in my neighbor's house, and maybe the police should go check it. And then, so somebody checks that, and then after somebody checks that, they make a determination whether or not to escalate that to an investigation. And then after the investigation happens, if it was found to indeed, if the allegations of abuse were indeed true, then the case goes to the CBCCF. So this is where the CBCCF steps in, and then they have to. It's not necessarily removal, but this is where they start working with the kid, and they wanted a measure for how for what the workload would be for both placements and services. Placements being moving the kid to a house, services being those like training, or even like they even help kids with like school supplies, stuff like that. So when the data science team got this, the first thing we did was the EDA, so exploratory data analysis. And these are the slides. These slides that I'm gonna show were the ones that we presented to the organization for after we looked at the data. In the initial amount of data, so the amount of data they gave us was around like 40 gigs, so definitely not enough for RAM. And the main table, I would say, was the case notes, and everything was kind of, you could join into the case notes. So the case notes would say this was the caseworker, and then you could find more about that caseworker in the caseworker table. Same thing. So all the allegations and investigations were separate from the case notes because there are many allegations and investigations that didn't become cases also. So, but then if if we if we wanted to look at a specific case, we also had to backtrack to the allegations and investigations table. And then placements, removal, reasons for removal, we could get from the person level case notes where they went and what were the reasons for removal. And there was also this family connections table. So since the data was anonymized, they would just say number one, number two, number three, and sometimes they would say like, oh, number three is the mom of number one, number four is the dad of number two, stuff like that. But this was only available for like 60% of the cases. So we didn't use it so much to build the model, but more for initial exploration. So looking at the so what we did was we divided all these tables amongst us, and so each one took a table or two, and then we looked at the data to see what it was showing us. So on the allegation side, the number one category is that family violence threatens child. And then we also noticed that there were some similar categories. Like you would see like sexual abuse, molestation, and then you'd also see like just molestation. And then there were also some really weird ones like neglect of child due to religious reasons. Oh. Okay, so yeah, there was like neglect of child due to religious reasons. So like let's say like there's physical injury up here. There's also bone fracture. So I think later on we grouped the similar ones. And then a quarter of allegations ended up being verified. So verified meaning it was moved on. I think what we discussed was no indicator, not substantiated. There were no more investigations after that allegation. Some indicator could still have an investigation after. So number of victims per investigation is normally below 5. So normally there's a bunch of siblings in the same house and the same allegation or investigation is like among all of them, like they were all abused in the same way. And the number of perpetrators. So you could see it's normally just one person doing the abuse, but sometimes it's both parents. Sometimes there's some grandparent or something. And then we noticed that 40% of the investigations were specifically with single-parent households. Not just so this is single-parent household, mother only, and then I think this is single-parent household mother, and then like with one significant other. We didn't cut these. These were literally like cut when we were looking at them, and we were just staring and like, what does 2B mean? And a lot of these things we had to bring up to get clarified. So like the 2B, so married two-parent households with 2B. B is apparently biological parent. Yeah, so mainly single-parent households were the main investigations. And then categories. So this is just on their data side how they label a specific case. So most of them are just cases and child investigations. But what's their independent living is kind of big. It's independent living is that livelihood training for minors who are about to hit 18, so that they can live on their own. And then special conditions also had some significant number. Special conditions referred to the just kids who need specialized care. So CF was for Central Florida, SEMI was for Seminole County. They gave us 2 sets of data of exactly the same tables. So apparently, all of these organizations. So we have CBCCF here in Florida, and then other states will have their own version of it. And by law, all of them are required to collect the same data. So whatever application we develop here would likely be also applicable to some other state because all the data is uniform. Although we kind of haven't been discussing that for a while anymore. But that was the initial goal that we create something that would be widely applicable. Median number of case notes, 145. So as you can see, there are just some extreme cases that end up lasting forever, hitting 1,500 case notes. Median number of people per case, around 10. Uh, and I think so. When we say median number of people, there's always like, so there's the kids, there's the parents, maybe some other relative of the parents. This will take care of the kids first, so that's also included. So it's literally everyone in the case, from placements to the people involved in the initial allegation and investigation.
Does it also include the person who reported?
No, they're not in the data at all.
Okay, so if somebody was calling out, harassing other people by reporting abuse,
Yeah.
this would not show that.
No. Yeah, the people doing the allegations, no, they're not here. What's sometimes the number of individuals increases because the case reopens with new people attached to it. So, for example, the parents abused a kid, and then later on they got their kids back, and then eventually they divorced, and then the mom has another guy in the picture or something, and then something happens again, then the case is reopened under the same number, and then it's just more individual. There's a different investigation attached to it. There's a different case type attached to it. So we're looking at what the workload for a caseworker is, and there was a caseworker table. So we saw that in a month they log activity for 3 cases, and this is really lower than what was expected. And we talked to the CBCCF about this. We said, I thought the average number of cases would be around 50 to 20. Why are they only logging activity for 3? And what they found was that what we realized is that a lot of times caseworkers will just pass on the notes to admin people to record it, and then the administrative people would be the ones would have their caseworker IDs attached to those cases. So yeah, we had to filter out later these administrative workers. Yeah.
That on space, that if I understood you, that sounds like almost a nightmare to get to the point of keeping the caseworkers on the job when the numbering system just got screwed up by how the numbers were put into the system.
Yeah.
Good.
Yeah. From a data quality standpoint, like it's pretty bad. It's like, it was pretty like one of those like, from a data scientist perspective, kind of one of those like, oh man, this is a mess. Yeah.
So I have a question. Were you able to go back? Was there like a number assigned by the child? Is that how you were able to go back and?
No, we didn't go back and correct this. What we did eventually was we filtered that we want caseworkers with a certain number of cases. Yeah. That we said like we want caseworkers with a minimum of 10 because we know those are the guys putting in their notes. So going along with the fact that they're administrative workers, we saw so the average number of notes was 150, and there were some people with more than 10,000 notes. We didn't know that these were administrative people yet until we talked to the CBCCF, and that's how we found out that those people are actually responsible. I think there was a flag later on that so when they gave us the data, there was over 40, 50 columns, and they only gave us the meaning of like 10 or 12. and they said these are probably the important ones you're gonna have to use. So this was one of those columns that we didn't know that flag meant it's an administrative worker. But also, on the caseworker side, we could see it's kind of sporadic. Like if you look at Blue over here, like he didn't have case notes for like 2 years, and then suddenly or actually 4 years, and then something popped up. And also there seems to be no consistent. Well, maybe there is a bit of a consistent pattern. So yeah, we grabbed like 6 caseworkers. We plotted their activity over the time period. And then in caseload, so yeah, number of cases. We said the median was 3, and then plotting their number of cases. This is like we were wondering why is it so low. So it seems that majority of the case notes were being written by, again, the administrative staff.
Let me ask you a dumb question.
Yeah,
They were taking paper notes and handing them to another human to do the transcription.
exactly. But when that happens in the system, it's that person who actually typed it. Yeah.
So were they flagging who they got the notes from? Is that what the other column flag was telling you, that this is actually pertained to child 123 when visited by caseworker 2?
Yeah. I think you could backtrack that. Yeah. Based on the people involved and what was going on, because the case notes on the person level have a kid attached to it, and then the kid you could see what case they are. From the case you could go caseworker. Yeah, you could.
So they were still doing this in paper, because I knew someone who was working in the field 5 years ago, and I thought they were using computer systems to enter their notes by then. And the data you're showing looks like they weren't.
I know some people had tablets with apps that they could, but a lot of people still use paper. Yeah. And then level of investigation. So courtesy investigation just means that the CBCCF, the kid moves states, and the CBCCF is still kind of looking after the kid, so they just check up on the kid in another state. And then I forgot the difference between primary and secondary. I think secondary is just a follow-up investigation, whereas primary is when it actually opens. So this could be like a case is reopening in the future. Removals by zip code. We thought it was interesting that removals seem to be concentrated like here, up there, and here also. This is something we didn't really get an answer for.
What's the definition of removal?
Like when they actually have to pull a kid out of the house and either take care of him or find a foster care home for him. But then what we were wondering, when it came to placements, there seemed to be one hotspot, and we were asking like, is that intentional? Is there something going on there? And then we were told that it's actually like they have a facility there where they take care of a lot of kids. So we didn't.
Which county is that?
I don't know.
Okay.
Yeah.
Is that where that group home is? Okay.
Yeah, that's a group home. And then so common reasons for why placements end. So placements are when a kid is brought to a foster home or adoption. So you could see that. Sorry. Basically when they move placements. So you could see here stuff like child ages out, right? So they become independent adults. You could see stuff like the parent, relative, guardian requested change. And then number 1, provider requested change. So the person doing, in charge of the placement requested for it. And then reunification with parents. So we use this data later on when we built our model.
So who's the provider?
The provider are they're agencies so the CBCCF coordinates with other agencies also that provide services. Yeah, and some of those I think are responsible for placement also. Like foster home. I think that's a placement too.
Okay, are these unique or can a child's case be in multiple categories?
For everything that we discuss, allegations, investigations, a child's category can be a child can be in multiple categories. Although for this one specifically, when I say it can be multiple categories, it can mean that a child had this placement, and then something went wrong, and then they went to another placement, and then another thing would pop up for that same kid.
Let me give you an example. Maybe explain it to child. There was a girl, she had HIV. She was in foster home number 1. Her notes showed up. They wanted to transfer her to the next one. She went to 52 foster homes in 52 weeks. So each of those might count towards the top line because the placement is foster home X. On the other hand, we knew some people who in our parenting group only adopted kids with HIV. Hers was the last placement, and she would then have a final step of adoption placement.
But she could show up at top line.
I think she's every time.
Yeah, it would be every time. Yeah.
Think of it as every dress they move to.
Yeah. And this is something we took into account later on in the modeling process also. Special cases, we were just wondering, what are special cases, and we brought this up. So this meeting was basically us bringing up all our questions about all the data we couldn't understand, and just having them answered. So special cases, just those people who need special care, have some, could be like disability or something.
Blind.
Yeah.
They need a heart operation. Deaf kids, are they in there as well?
Just all of those, like yeah. So that was our exploratory data analysis, and then we had the slide for questions for the partner. And I just wanted to show you guys what our progress was after 2 months of looking at the data. And our number one question was, how do we know if a case is open or closed? So after looking at the data for 2 months, we still couldn't find out what defines a case being closed. And the reason for this was there's no real flag that a case is closed. It's just basically the last date, but then it can be reopened under the same number. So there's no definitive answer like, oh, this case is definitely closed. End of a placement, we covered that. How often do new cases come up? So as we were thinking about how we're going to do the modeling process, we were asking our partner, how often is this model going to run? How often are cases assigned? How often are they should we be calculating the workload of a caseworker? And basically the answers to these were cases. It's an every week basis. So they wanted the loads to be calculated every week, and then that week they would they would assign new cases, and then the next week they would have a new set of workloads for each person. And then this one, the time window. So we were already discussing that we need to limit the window. We can't be predicting like a caseload for the next year out, or maybe 2 years out. Maybe the case will close by then. So we wanted something. We were already bringing up the idea to our partner that maybe we have to limit the scope into something that is accurate in the near future. And because we know for sure it will be less accurate the further out we go. And also during our exploratory data analysis, we came across this very interesting article, and what they were doing was they were using machine learning at the allegation and investigation stage to determine which children are the highest risk, which are moderate risk, and which are lower risk. And the article was saying that the problem with this machine learning model is that when it fails, like for example, it said a kid was low risk, and then the next year they could be dead already because of the abuse of the parents. So basically, one of the reasons we were doing with the caseworker side and just helping them is because we don't want to use machine learning to make those high risk predictions that have major liability associated with them, because it could be very damaging.
You're saying this organization was doing this?
Not this one, but I think this was in Maryland that they were doing this. So yeah, we came across this article. We were just reading a bunch of articles at that time about the whole system to get an understanding. And one of my teammates, she works for Memorial Sloan Kettering Cancer Research Center. She said also that in her work experience, sometimes they don't want to put the diagnosis. So what they do is they just put all the relevant information in front of the person doing the diagnosis in a way that's easy for them in a way that will help them make a faster decision. So we're 2 months in, and our team still didn't have a clue. Really, we still didn't have a picture of the entire process. So we had a team member who was also in Orlando, but she's now moved to DC. She was working for Disney here as a data scientist, and her interest was data visualization. So we asked her specifically to get one case, join all the relevant tables, sketch out the entire case, so that we could see what's going on. And we did it for 2 cases. One was for a case with a removal, and the other was for a case without a removal. But I'm just going to show you one. So these things were pretty long, but we went through them with the project partner also, and CBCCF also told us that they learned a lot from it. So quick facts about this case. It went on for 5 years. There were 4 daughters, 4 adults, and this is one of those cases that had the relationships attached. So the allegations changed each time. We're going to see this, and the reasons for service also changed each time throughout the case. So this is the family tree. There's father, mother, there's a grandfather, and then the 4 daughters. There were 14 caseworkers. So the CBCCF told us, don't worry about the secondary so much. It's really the primary you want to take care of. You want to know. And then there was no overlap between this and this, but there was some overlap here. And that's because one of these guys is listed as both a primary and secondary, which we were unclear about. Again, that's an issue with data quality. So timeline of the case, there was an investigation and a field visit. So nothing happened out of that. It wasn't substantiated. And then 3 years later, there was another phone call and investigation. Again, it didn't become a case yet. And then September 9, there was another investigation. And then this is 2013 is when it became an actual case. And then it went all the way to June 17, 2014. So investigation 1, so it was substance misuse, and you could see these are all features we included when we built our model eventually. So response priority, was it an in-home kind of event? What was the living arrangement? So a while ago when you asked, do these things, can a child be under multiple categories? So even these things will change over time, right? So when we trace one kid and their timeline, we'll see multiple allegations, whether or not those were substantiated. So investigation 2. So the first one was substance misuse. Now it became family violence threatens child, right? And now it's only 3 of the daughters included. We asked, and they said there are times when it's just one kid that they're pulling out. It's not all the kids. So yeah, maybe it could be daughter 1 is also out of the house now. Not sure. It could be many things. So these are the activities that happened along with that investigation. So there was a home visit to the child current residence. There's a home visit to the parent. And then investigation 3, we were back to substance misuse. It was the mother, and this time it's verified. So at this time it became a case, and they actually had to provide services for the kids. And then investigation 4, substance misuse, again, the mother. Um, so, uh,
Quick question.
yes, yes.
Back there when you were showing it, you were showing that they were living with their father only, and you have all these allegations against the mother.
So I think this is
Did
since
they remove the mother or remove the children or?
yeah, either because so this is July 5, 2013. I think from this one the mother was already verified for the substance misuse, so they did either of those. Either they just kept them with the dad or they kicked out the mother. Yeah. So at that point, we got a better understanding of what actually goes on in a case. So we did that for like 4 cases total, and we saw a variety of things. We saw like let's say um, like there was the mom got another guy in the picture, and then things were going out of control. Like there was stuff like that. Um, and then so at that point, after we finished, this is like maybe we're already in February of 2018, so 3 months in, and we decide we're gonna start building our minimum viable product. So we would just wanted the simplest iteration, see if this task is possible, measuring case complexity, seeing if there's signal, and seeing if machine learning can be applied here. So just to give a recap of the things they previously asked, um, so they wanted to give specialized cases to specialized to certain people, and they also wanted to take geospatial information into account. On these two, we weren't able to get there, but we were able to measure the complexity. Yeah. So the first question our team dealt with was how do we measure complexity, and I think uh, the first time we were brainstorming about it, we were wondering, is it possible to predict the end date of a case? And this would tell us, hey, this caseworker would be freeing up, next month, or this caseworker will be freeing up next, in 2 weeks. So we could use that to balance caseloads. And then, eventually, as we developed with our project partner, what we did end up with was um, activity rate. So how many hours is a caseworker working on this specific case? So what we saw was that so once we came up with this metric, we then explored what is the distribution of this metric. We expect something normal. Are there hard cases? Are there How long did those take? Um, so yeah, this is the metric that we chose, and the main reasons were that it's very easy to understand for all parties involved. It's very easy for a manager to say, oh, that case will take my caseworker 5 hours to do in the next 2 months. So it's very easy to understand, and it's also something very actionable already. So we chose this as a metric, and then our goal was to model to see can we predict what the activity rate for this specific case will be. Again, iterating with our project partner, what we said was that we definitely cannot make a prediction too early. So if a case just comes in and there's no information attached to it, we said there's no way it's a cold start and we can't make a prediction on it. So what we said was that we'll predict cases that have 6 months of data already, and then um, we're going to predict the next 2 months of work. And again, this is something that will be run on a weekly basis. Any questions? No? Okay. So, what we did was for each of the specific. Did you have one? And that, so what we did for each of the specific cases was we we got time blocks, and then we calculated what would the activity rate be. So for each case node, that was for each type of case node, again, we went to our project partner and said, can you quantify how long a case visit is, how long this activity is, how long that activity is? And we had a long list of them, and we just mapped the value to them. And then we used those values to calculate. So we went back in, we looked at the data and we said there was this much activity, and in a total, this is probably the approximate number of hours they spent. So we saw for this case specifically, there was an average of 5.75 hours for over the 2 months. So yeah, we went to the transforming all the data into the format that we needed. So in determining eligible cases, we had cases there that were in the data when we looked at the distribution of the case lengths. We saw cases in the 20-year range, 40-year range, and obviously that's wrong data, right? Because kids graduate out of the system at 18 years old. So the theoretical max should be 18. So that was an issue with caseworkers marking, inputting the data incorrectly. And then we said that the case needs to have at least 5 case notes, because if we don't have an initial start, then it's hard to make the prediction. And then we wanted caseworkers with 10 or more cases, so we know that these are already experienced caseworkers. This is a normal thing. We also took out all of the administrative people, because again, the caseworkers with below 10 cases, they may be handing off their notes. That would be inaccurate in calculating their activity, or it would be significantly harder. Yes.
So there's only one case per individual.
Sorry.
Per
person.
Per child.
Yeah.
Child human. There's only one case.
Yeah.
Per.
Yeah.
Okay.
And I think so.
Because I can answer your 40-year question.
Okay.
There's a mom who started out 40 years ago when she was 14 and had a child. She proceeded to have 12, 14 children.
So these guys have just been. They started in 2004.
Right.
So I don't.
So between now and 2004, they're having
Right,
7 years.
right.
Okay.
Yeah.
So you've got garbage data. That's a
Yeah.
different story. Yeah. But if
But
the
the
involvement
cases-
of the sorry. go ahead.
The case is a child, correct?
A case,
Or is it a family?
a case can be like a while ago when we did a timeline of a case, there were 4 children there.
Okay, so that would be considered one case, those 4
Yeah,
children?
yeah.
Okay.
Okay,
So it's by the simply
so
order.
she
Okay.
would get out,
Yeah.
show up in court dressed up nice, and continue having custody of these kids. So she's had multiple children who've aged out of the system, never got adopted, because she never lost custody. And she's done, her oldest 5 kids have come through. So her case could
Yeah.
span
I could see
25
that.
years.
Yeah. Yeah.
But that doesn't discount the very high odds that you have junk data.
Yeah. And I said a while ago that we felt, the data set after we did our filters was kind of thin. So the case notes was like 6 million, and then we filtered out a lot of those rows. And in the end, we only have 8,900 cases. And from
6 million?
no, sorry, those were rows of case notes, but many of those, like 150, could belong to one case. So 20,000. So we had 20,000. We went down to around 9,000 cases. And from a machine learning standpoint, when we were building out our feature set, we were, hitting around 300 features for 9,000 data points. It's not the best ratio. Yeah. So definitely we could have used more data. And going back to what you said, when you were asking about the caseworkers, doing it on the caseworker side, predicting if they're burning out or if they're going to leave, I would say it's unlikely that there would be enough data for that, considering that their main data source was the notes. Yeah.
Do you guys think of any kind of textual analysis on text notes?
There's so I'm gonna announce like a volunteer opportunity, and it's gonna be that yeah. So activity in the case data set. So a lot of cases there was just no activity, and then this one seems kind of high. There was I guess there was an activity, a case that for 2 months they had an average of 159 hours of activity, But then later on, we found something with like 380 hours of activity, and there was just like so many people attached to it, to that same case, and it just kept the child. I think it was a runaway child, and he ran away like 4 or 5 times in that duration. So again, these were the tables that we had, and we started building out our features. So each of those, let's say, what was the reason for placement, or each of those, like what was the living arrangement, we use those as features for the model. Um, so it's pretty much, most of them are, I would say, the initial data. The only thing we added are mainly on the placement sides, where we had the number of placements in the case and the number of zip codes, different zip codes. And we found that the zip codes had a lot of predicting power later on. So what we did for each, so for the data scientists, count vectorizing and one-hot encoding, they're the same. So we one-hot encoded everything pretty much. So for example, the investigation, we would just count them, and we would say, oh, there were 2 investigations in this case. There were 3 home visits, 1 telephone contact, 2 placements. What would what is the, and then we asked the model to determine what would be the activity rate for the next 2 months. So on this unique activity, it's broken down even further, right? So under investigation, you'll have the different investigation types, the different, living arrangement. Was it primary? Was it secondary? And all of those would have their own column, and each of those would be counted, how many times that happened. So for a kid with a lot of activity, you would see a lot of values, and for a kid who maybe just had 1 investigation done and just a few case notes, you would see so many zeros also. So in general, it was a very sparse matrix, and we used sklearn's sparse matrix to manipulate things, to make it faster. So the modeling process, so once we transform our data, we split it, train, validate, and test. The trained data was 60%, validate 20%, and then this one was the holdout that we never touched until the end, when we actually looked at the metrics after the whole process. So for the model, we were thinking of decision trees because they're very easy to explain also. You can see what actually contributed, and they also work really well for one-hot encoded data. Whereas when you deal with a regression type problem, there's an assumed difference between 1 and 2 and 2 and 3, but then when it comes to decision trees, it could just say, oh, greater than 1, and then that's your feat. It could just look into that. So, and there were many outliers also. Like, I mean, considering that there are a lot of cases where, like, let's say the kid ran away 5 times, then once we normalize everything, it would really reduce the normal amount of times kids run away, which is like 1 or 2. So that's why we chose decision trees in general. The VMs Microsoft gave us were not good, honestly. You couldn't do anything. Definitely deep learning out of the question, and especially with the data size, probably out of the question. And that's why we stuck with the random forest. And then for our metric, for the model, we used the mean absolute error. And we chose this because it's very easy to interpret. We can easily say our model is off by an average of 2 hours. Or our model is off by an average of 1.5 hours. So the mean absolute error is just the average absolute value of all your errors, and of the actual hours minus the predicted hours. And then we could just, this was, although they say like, for decision trees, your RMSE could be better. We felt that performance was the same in both, but this one is way easier to explain and understand for our client. Yep.
In the previous slides, you mentioned that the zip code also showed up as the ones for us. Yeah, so the zip codes, you said that it showed up as a good predictor.
Yeah.
Did you use that as a response to
No, as is, just normalized. Yeah, yeah. Kids with a lot of activities and a lot of placements, they tend to have high zip codes because they're moving all over the place. And yeah, so we just counted the number of zip codes that a unique zip code that a child has been placed with because that's a strong indicator of the amount of activity. Yeah. So here's a picture of what the decision tree would see for those not familiar. And it would just, branch out true, false, and then it would just use these to make predictions. And then when you have a bunch of decision trees, that's when you call it a random forest. So you can randomize how much data you're training the decision tree on, or what features you're training the decision tree on. And then once you have a lot of these, weaker predictors, when you ensemble them into the forest, you get stronger predictions. So here's the random forest, and each one of these would be a tree that has different predictions. So those would be average, and then the average of those would be the final prediction. So initial model, I want to specify that when we did our initial model, we literally just took the start. We had 9,000 cases. We literally just took the start of all of them. So the first 8 months, right? The first 6 months for training, and the next 2 months for prediction. And this was for simplicity, just to get an initial model up and running. But it's also because we would have to filter out, let's say there are cases with long pauses in between. We didn't yet build our our sampler to go through, find those windows, and then use those windows in our model. So this was the initial prediction, and I think what we saw was that the mean activity rate was like 3.6, 3.7 hours, and our mean absolute error was around 2 hours. So it's for we were thinking, is this good enough? Is this a ceiling we could reach? This is already the simplest model. Is this a ceiling we could reach? Would this be something good enough? And I also want to point out all the points along the axes. These are there was no activity. We predicted there was activity, and vice versa. We predicted no activity to happen, and then there was activity, and there were a lot of them also. And in general, we were over predicting. So we brought up these results to the CBCCF, and what our partner told us is, I don't know how statistics work, but hopefully if you're under half of the time, and if you're over half of the time, then you have 10 cases. Hopefully it balances out, and you can come up with an accurate prediction. And we said, yeah, that's likely what we would resort to. So what we did was we grouped a caseworker who. Oh, this is the distribution. So in general, we had good agreement. It's just these major outliers dragging the mean, and you'll see one of them next slide. Oh, so before I get to the aggregating, this is what I said. The number of distinct zips happen to be a good indicator. So what's nice about decision trees is that you can get the nodes which had the most impact, which features had the most impact. And these were the 20 that we got. And what we did was we just put them on a slide, and we just showed them to the CBCCF, and we asked them, hey, do these make sense? Does something look off? And he said, yeah, it pretty much makes sense. It looks good for now. So here's what I was talking about. So we got one caseworker with that ID, and we got the 10 cases that he was the primary caseworker. He or she was the primary caseworker for, and then we looked at how our predictions did. And here it is. So in blue is the actual, in red was our predicted. So here there was agreement, there was nothing. Here we predicted 4 hours, but it was around 16. And in general, we were over, but looking at this specific case, it seemed like there was potential that maybe when we aggregate on the caseworker level, that measurement might be correct, might be at least reasonable, a reasonable indicator of what their workload is. And then we looked at specific cases also. So we said, what are the, let's apply this model to specific cases. Let's see what our error is. So this is a case where there's good agreement. The rate was, 5.1. I think, so the real rate was 4.7 hours, and then we predicted 5.1. So we over predicted by 0.4 hours. And in general, it seemed like we got the features, and it seemed to be working okay. Same thing here. We did for each of the times we're doing this, we're getting the most important features. Same thing here. We were just looking at the different cases. Just checking the time. Oh wow. Okay, I need to speed up. Okay, so after the MVP was built, then we decided we're not just sampling the beginning. Now we want to do the real thing. So out of the 9,000 cases, we did 1/3 in the beginning of a case, 1/3 in the end of a case, and another third in the middle of a case. And hopefully the one in the middle would have activity associated with it. And then we decided to just refine our model. So second run. So here's the 1/3, 1/3, 1/3. Because we want to be able to predict cases throughout the whole case. So like even if it's in the middle or ending, we want to be able to predict that. So we sampled accordingly. And things got worse. And this is one of those when we were meeting our project partner, the CBCCF, we were like, we don't know how to tell you, but our current model is doing much worse. Our current mean error is around 4 hours and 30 minutes. And we were kind of frustrated, and we thought maybe the issue is that we don't have a big enough sample. So because we did the 1/3, 1/3, 1/3. So what we did instead was that for one case, if it was 5 years, we took a sample from the beginning, the end, maybe we took 3 windows in the middle. So we were stretching out our data so that we could get more training and testing data to use. Frequency distribution, again, it's the outliers killing us. And then we added model interpretability, just a plot that's displayed for the managers who use this tool. And then again, we asked them, hey, is this reasonable? And the one that we were really confused about was number 2. It says mobile device who present at visit. And we asked CBCCF, what does that mean? Does it mean if a kid is holding their phone in a visit? And we eventually concluded it was like an artifact of some other aid partner that they work with. If their caseworker goes in and is holding a tablet, they record that. And for some reason, it was a strong indicator. I think we left that in the end. So again, individual case interpretation for the newer model. So like this one is doing so bad. And then I noticed a major error in that we were getting a lot of artificial zeros because like when we sampled the end of the cases, we didn't take into account that our data is cut at the end. So clumsy mistake. And then we decided, oh yeah, we can fix this. We can just shift everything back and then because there was an artificial cut at the end, so we moved everything back so that when we're doing the end of a case, we do have an 8-month window. We were doing that incorrectly first. But then this didn't fix much either. So by the time we hit the final presentation, what we decided was that we're gonna bin the cases into low complexity, medium complexity, high complexity. Because if we cannot get a good accuracy giving a number, then we decided we'll just bin them and let the case manager decide. So this was our distribution. So in general, after we stretch our data set, we lost some, we gained some. It's still around 9,000. And then for the distribution of the cases, it's as we want, it's kind of normal with a chunk around the medium complexity. And then again, features. So here is what our accuracy looked like. And in general, we were around, so low, for the low class, we were 75%, 79%, 65%. But what we said was good about this model is that if 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 um, if we didn't predict it as, if we incorrectly predicted a low case as medium, at least it's not so bad, right? What we don't want is that like high and low has no distinguishable difference. We want that if it's wrong, at least it's just in the one bin over. And we saw that there was good that at least this model was good at doing that. If it's wrong, at least it's not too wrong, right? And then again, maybe we took out the mobile device present at visit. So again, we gave our list of features, and again, they said it looked pretty good. So yeah, this is how we would use the model. We would give the prediction. We'd say low, high, medium, and then we'll give the actual hours compared to the actual hours spent, and then whenever we give a prediction now, we give the model confidence attached to it from the random forest model. And then we also give the top 10 features for the case manager to look at that contributed to this case. There's an issue with the features in a random forest. When you look at the random forest and you look at the metrics of the top 10 features, there's this weird like, oh, this added 2 hours to the case. This took out 3 hours to the case. This added 4 hours. And it was so weird to explain what it means that something took out hours from a case, right? Like it didn't seem physically reasonable. So we just listed the top 10 and then we left it at that. So yeah, so we accomplished the complexity model. In the caseworker specialty, looking back at it, I think we could have dove into the caseworker table more, and we could have added, we could have made caseworker features also, so that it would be. But what's hard about this is that even if we spit out a prediction, it has to be updated in some way depending on who's going to be receiving it. And then geography, we didn't really get it done. So lessons learned, number one, we had modular code so that we could have faster iterations, especially in the home stretch. This was really important. We had the CBCCF partner, we had a strong IT background, and then a lot of times we could give him SQL scripts that he could adjust to fit his own database, and this was really helpful in deployment. And then I would say this is the strongest point, communicating predictions. We decided to bin so that, because if you give people a number, they would trust the number, and we didn't want people trusting with such a high error, so we said we'll bin them. And then for me as a project manager, I should have probably integrated the two projects earlier. And then for me, what I got out of the project was, in my work, we use R and Microsoft SQL Server a lot, and I at least got to experience and see how other people, work, and I don't get a lot of opportunities to use Python. So getting involved in DataKind, I know there were some people curious. So what happens is you just apply online, and then you're part of the newsletter. When new projects come out, you get the newsletter, and then you apply for specific projects. But it just really depends when projects open. And then again, you were asking me, do they look at the case notes and see if there's anything in them for sentiment analysis? And what the CBCCF partner told me to announce today is that he's interested in a new project where they would look at the case notes and use that to predict placement stability, so that they could see if a kid will likely be removed from placement or if they need to do something rather than wait for it to happen. And so he's looking for volunteers. And the goal is to use sentiment analysis on the case notes and maybe other data points to predict a placement disruption. And he was hoping that there would be volunteers here. When it comes to DataKind doing the project, I talked to both parties, and DataKind said that there's no more funding for them to help the CBCCF, so he would have to do it. He would have to find his own funding, and that's why he's trying to organize a volunteer group. All right, thank you.
We have 10 minutes for questions. This is open.
Yeah.
Did you have any social scientists on your team?
We did, but he dropped out.
He wasn't available at the beginning.
Yeah, he was a professor, and he had a lot of night classes, and then early on he just said he couldn't commit anymore, and we decided not to replace him. But we did have subject matter experts on hand also. DataKind organized for us. They got some professors here and there who dealt with the foster care system, and also we always talk to our project partner. We have a very communicative project partner who always, although I wish sometimes he just answered all the questions. Sometimes I wish he also let us talk to the caseworkers, but he just kind of just interjected and answered all. Yeah.
Did you do any evaluation as you were doing your project? Like when the people were, your people that were volunteers doing the work, like how long it took them to do things, what was their scale of expertise?
Okay, as a project manager, yes, I try to see, who's good at what, and we move people between projects. There was a point where complexity was like struggling and optimization was doing so well, and I considered moving people. But at that point, the overhead was just too high. Also, we discussed what our skill sets were, and we gave stuff to people who could do them well. So for all the data engineering stuff, we had a data engineer who works for Yahoo, and we let him handle it. Although we also are conscious that this is a volunteer opportunity, and if you want to improve a certain skill set, we want you to have the opportunity to do that. So like most of these slides were made by that person who wants to do data visualization. She was working for Disney here, not in a data visualization role, but in mid-project, she got hired in DC for a political think tank to do data visualization to communicate the results. Yeah, so there's a lot of thinking about that. Yes.
So first of all, let me just say thank you. As someone who has essentially no background with data science, you made everything very, very understandable. So thank you for that. My question is, just as a data scientist, in what context or what circumstances do you go back and look at some of the extreme outlier data and try and work that into your model?
I think this is I don't know. For me, it's a case-to-case basis, but normally I treat outliers as something is wrong with the data and try to cut it. But if it's like, it's hard to tell if it's there's a real signal there,
Right.
and if I can reasonably say that there's a reasonable signal there, then I leave it. And I say that outliers will come in the future, and my model needs at least to reasonably with outliers.